let's take a look at a coordinate geometry question here from Kenrich. Now, I want you to pay attention to the diagram while we are reading the paragraph. Make sure all the information in the paragraph is in the diagram as well. Now, let's start reading. The diagram shows a trapezium ABCD in which AB is parallel to DC and angle BAD equals to 90 degrees. You'll notice everything is in. The point A is 0, 6 and the point B is K and all are in. The line with equation y equal to negative 3 over 5x plus 47 over 5 passes through M, the midpoint of AB, and through C, which lies on CD, whose equation is for y equal to x minus 27. Now notice that's one information that's not in. I'm going to place that in, which is this one here, midpoint AB. Let's just put it into the diagram. Now let's read part 1 question. Show that k equals to 8. K is both the x and the y coordinate at point B. So we know that we only need one information to solve for k value. Now we are missing midpoint there, so I'm not going to use midpoint. Now let's analyze the question again. You'll notice that we have these parallel lines, okay? So what I'm going to do is I am going to rearrange the line CD equation. Let me write down here. I have for y equals to x minus 27. Let me divide by 4. So notice this is a gradient for line CD, which is also equal to gradient for line A to B, which is 1 over 4. And I'm going to place that into the diagram. Okay. Now, because I have point A as 0, 6, I'm going to use point B right now with this gradient 1 over 4. So I have k minus 6 divided by k minus 0 equals to 1 over 4. And I'm going to multiply this 4 to the top here for both k and 6. So I have 4k minus 24 equals to, and we're going to multiply k minus 0 to the right hand side. So I have 1k. So I'll just write k, 0 I don't write anymore. So rearranging, 3k equals 24. So k must be equals to 8. Alright, so we have solved for part 1 here. Now let's take a look at part 2 of the question. Find the coordinates of C and of D. Let's just observe point C first. We notice that C is on the equation that's already given to us. But since the equation is not so nice, what I'm going to do is I'm going to multiply by 5. And I'm going to rewrite the equation as 5y equals to negative 3x plus 47. Alright, so this is my line number 1. Let's take a look. I have also the other line, which is the green color arrow over there that we have drawn just now. I'm going to use that equation too, and maybe I'll rearrange also as 4y plus 27 equals to x. So right now, I'm going to substitute 2 into 1 to find a point intersection, which is point C. So now I have 5y equals to negative 3. X value I'm going to substitute as 4y plus 27. Continue writing plus 47. Okay, let's solve for this one here. Multiply negative 3 in. I have negative 12y minus 81. Moving y one side, 70y. Adding the constant, negative 34. Y will be negative 2. So I have the y value here. I'm going to substitute y into equation number 2 to get the x value. So x is 4y plus 27. Okay, so for this one here, I will get 19 as my answer. Let's conclude. Point C will be 19, negative 2. Just be careful which coordinate you are writing first. Okay, let's erase part 1 here and let's continue with part 2. We are still in part 2 here. We are still pending for coordinate of point D. So point D over there falls on 2 lines. One is the green one that we have labeled as 2. Another one is the red one that I have just drawn out. So you can see that there's a perpendicular notation there. So which means I can easily form the AD line. So what I'm going to do here is that I'm going to first find out what AD line is, which is perpendicular to the green one, where we already have the gradient of AB just now as 1/4, which means gradient of A to D will be perpendicular to this, so change sign, swap reciprocal. Line AD will be simple. I have y-intercept as 6. Alright, so I'm going to form the equation by using y equals to mx plus c. So I have negative 4x plus 6. That's a line for AD. Let me label this as 3. Okay, now I'm going to solve point intersection between line 2 and line 3. I'm going to sub 3 into 2. Let's do it now. I have 4y plus 27 equals to x. Let's expand this one here. Okay, so I have 51 equals to 17x, and x is equals to 3. So let me put back this x equals 3 into equation number 3. So I have y equals to negative 4x plus 6. Right, so I'll have a negative 6 here. So let's conclude point D as 3, negative 6. So we're done for part 2. Let me erase the whole thing and we'll take a look at part 3. Part 3 of the question, find the area of trapezium ABCD. Now I'm going to show you two methods here. First one is what we commonly use. So I'm going to start writing area formula. So I'll say half, and we'll start with a coordinate. I will start with point A because it consists of 0. I like that. Let's now turn anti-clockwise. So I'll go to point D there. So point D here just now we already found is 3 and negative 6. And continue turning. For that diagram will be point C, 19, negative 2. And turn again, we have 8, 8. Remember to turn back to the original point, which is point A, that's 0, 6. Next, let's do this by multiplying this number over here and add them together. So 0, I get 0, usually I don't write. Let's continue. This negative 6 and go multiply 19 times 8 using my calculator here. I'll have 152. This one I can do. 8 times 6 is 48. So I'm done with the downwards multiplication and add them together. The center here is going to be minus. Let's do the other direction. This way. Alright, so I can do 6 times 3, which is this one here. And this one, let me click my calculator. So this one, I will get negative 114. Right, this one I can. So this is a negative 16 and 0 I usually don't write. Let's close it. And remember to put a big bracket over here. Now let's click our calculator for the addition inside the smaller bracket first here, which is 194. And this bracket over here will be negative 112. Now I can proceed to click everything now. So you'll be getting 153 unit square for the area of the trapezium. Now let me erase this one here. I'm going to show you another checking method. So in case you have extra time, let's do that. Now let's take a look at an alternative method to find the area of trapezium. So I'm going to need the parallel sides, the length of it, and also the height of the trapezium. Let's do a distance formula. I'm going to get AB first. Length of AB is going to be 8 minus 0 square plus 8 minus 6 square. Let's click our calculator. So this one here, I'll have square root of 68. Let's proceed to the parallel sides, which is D to C. Distance formula again. So we have 19 minus 3 square plus negative 2. Double minus negative 6, I'm going to switch it to plus. And this one here will be getting square root of 272. All right, let's look at the height of the trapezium, which is length A to D. Let's do another distance formula. So I have 0 minus 3 square plus 6 minus negative 6. So I'm going to do 6 plus 6 square. And this one here, I'll have square root 153. Okay, so these two are the parallel sides. So formula for trapezium, half, add the parallel sides together and multiply by height, which is square root 153. Let's click this in our calculator. I should be getting 153 units square, the same like just now. That's all for this question here.